Welcome, and thank you for viewing this presentation on utilizing green stormwater infrastructure to improve surface water quality. This is part of a series for the Keeping Water Clean in White Lake project, funded by the Community Foundation of Muskegon County's White Lake Fund. My name is Carlos Calderon, WEMIAC's Director of Sustainable Community Development. I'll be running through some basic concepts of aquatic natural resource management. First, I'll introduce our organization and background, then we'll move into the components of the water cycle and watersheds, including the White River-White Lake watershed. Then zooming into some of the pollution sources that impact the watershed. Finally, looking at nature-based solutions that can reduce the impacts of pollution. WEMIAC has served the West Michigan community for over 50 years, beginning in the 1960s in response to the environmental crises facing the Great Lakes Basin. Our mission is to work collaboratively alongside our diverse community to educate, engage, and advocate for environmental values, environmental and climate justice, and a healthy and resilient community for all. To support this mission, our water programs have offered a variety of ways to engage and partner with the community. Now I'd like to talk about the water cycle and watersheds. Features of the water cycle describe the multiple states that water exists in the environment. Primarily a liquid, water is stored in large water bodies such as lakes and oceans, and cycles throughout the landscape across the seasons. Water is the conduit of life and interacts with plants and other organisms to exchange energy and chemicals such as carbon dioxide, sugars, and more. The landscape that receives and stores water is referred to as a watershed. This area of land shares a common drainage point such as a stream, river, lake, or ocean. Everyone lives in a watershed, and they can be nested and delineated at various scales. For example, the roof of your home or business is a watershed that likely drains into the street or ditch, which drains into the nearest stream. As human development altered the land, the rate and proportion of distribution of water was thrown out of balance with natural processes. White Lake is a drowned river mouth that is the receiving water body of the White River watershed before it drains into Lake Michigan. The entire watershed drains parts of Newaygo, Oceana, and Muskegon counties, over 538 square miles. Density throughout most of the watershed is low until we get to the White Lake area. Fruitland Township, White River Township, and Montague Township make up the majority of the shoreline, with nearly 1,000 properties within 500 feet of the lake. You can see dense drainage areas on the north side in the Pearson Swamp District and the Montague Drain District, as well as impacts from Whitehall and Montague itself. Pollution can be divided into two main classes: point source, originating from a single source like a pipe, and non-point source, an accumulation of drainage from across a large area. Most point sources are less of a concern since federal and state regulations have been enacted. It is uncommon to find industrial point sources draining directly into water bodies. Most have been removed or managed through the Clean Water Act. Non-point sources are more difficult to manage. These man-made sources include agricultural lands, urban development like parking lots, roads, roofs, and stormwater drainage systems. The cumulative effects of these sources result in high concentrations of chemicals and physical pollutants such as sediment, chloride, and pesticides. When addressing non-point source pollution, the preferred methods or best management practices are described as nature-based solutions. These BMPs are designed to mimic the natural processes of the water cycle to restore function to the ecosystem and are commonly referred to as green stormwater infrastructure. These include a variety of practices that are designed to suit the space and drainage area of focus. Green stormwater infrastructure BMPs range from residential scale practices like rain barrels, rain gardens, and other natural landscape methods. Green stormwater infrastructure BMPs can be applied to large areas as well. In commercial and public spaces, larger, more sophisticated designs are required. Converting impervious spaces like parking lots into permeable area, incorporating bioretention structures or native vegetation can significantly reduce stormwater runoff. Many communities are installing and implementing green stormwater infrastructure BMPs along streets, in parks, and on top of buildings to capture, infiltrate, and recycle excess stormwater. Thank you for your time. If you have any questions about green stormwater infrastructure or how you can help manage stormwater on your site, contact us at www.wemiac.org. Have a great day.